In this session, we will create a clustered heat map using Seaborn library. The cluster map creates a heat map and a dendrogram. So it is going to be two visuals in one. Heat map shows the correlation between variables. The top and bottom dendrograms will suggest how variables cluster with each other horizontally and vertically. The dendrogram that I just mentioned is a visual way of showing clusters. Clustering is an unsupervised machine learning algorithm, and the dendrogram attempts to create groups based on simple correlations only. We will create a synthetic data set containing spending score, income, age, savings, and investment. The data set is created using the random number generation, and the data set thus created is converted into a data frame. We create a correlation matrix that is needed for the heat map. Correlation matrix essentially tells us how correlated the variables are. It tells us whether there is any positive or negative relationship. If I earn more, will I save more or less? That is the kind of relationship I'm intending to know. Finally, we create a cluster map. The color gradient that you see represents the magnitude of the correlation coefficients between the variables. In this heat map, red indicates a positive correlation, blue indicates a negative correlation, and white or light blue or light red suggests little or no correlation. The numbers in each cell of the heat map are the correlation coefficients ranging from -1 to +1. A value of +1 means a perfect positive correlation, -1 means a perfect negative correlation, and 0 indicates no correlation. All the values in the diagonal row are 1. It is because the comparison is with the same variable. The tree-like diagrams or dendrograms on the left and right side of the heat map represent the results of the hierarchical clustering or grouping. They show how closely related the variables are to each other. Branches that join closer to the root of the tree represent variables that are more similar. Income and savings are closely related as they join at the lowest point in the hierarchy. Age appears to be less related to other variables since its branch joins later in the hierarchy. The main takeaway from this heat map would be the relationship between different financial metrics. Investment and spending score have a negative correlation of -0.21, implying that as investment increases, the spending score tends to decrease or vice versa. The rest don't have any relationship as indicated by correlation coefficient closer to 0. Even the value of -0.21 is closer to 0. None of the variables have a correlation coefficient closer to 1, either in the positive range or negative range. Such weak correlations are expected in synthetic data set like the one that we have created and used. When you use real life data sets, you can expect at least one variable exhibiting a strong correlation. Looking at the dendrograms, we can infer the natural groupings or segments in the data. For instance, you might consider income and savings as one group due to the close proximity in the dendrogram. Such insights can inform strategies for customer segmentation, targeted marketing, and product development.